At exactly on the 27th of February, 2026, something happened in our solar system that should not exist outside of science fiction, and yet here we are, staring at the data in real time. 8 hours ago, multiple independent observatories confirmed an event that breaks the most basic rules we use to understand motion, gravity, and energy. This is not speculation, and it's not a simulation. This is a recorded physical event involving an object we once believed was nothing more than an interstellar comet. That object is known as 3I, Atlas, and today it forced physicists to confront a third option that our laws of nature say should never be possible. To understand why this moment matters, imagine an object racing through space at 180,000 kilometers per hour while plunging into Jupiter's immense gravitational well. According to Newtonian mechanics and Einstein's relativity, there are only two possible outcomes. The object either accelerates and slingshots away, or it collides and is destroyed. Gravity does not negotiate. There is no pause button. And yet, at precisely 4:15 UTC, 3I, Atlas did something no natural object has ever done before. It stopped, not slowed down, not redirected. It reached zero velocity relative to Jupiter almost instantly without producing heat, debris, or exhaust. NASA's Goddard Space Flight Center initially assumed the telemetry was wrong. That response was reasonable because an event like this should not survive basic error checking. Instruments fail, sensors drift, data glitches happen. But that explanation collapsed within minutes. The European Space Agency's Gaia Observatory independently confirmed the same coordinates. Then the ALMA array in Chile observed the same region using an entirely different detection method. Three separate systems on different continents using different physics all reported the same impossible result. The object was stationary, suspended in a region of space where Jupiter's gravity should have torn it apart. When physicists see something like this, the instinct is to recheck assumptions. You look for missing variables. You search for numerical instability. But the math does not budge. The odds of a natural object entering a hyperbolic orbit and then achieving a stable, geostationary position over a gas giant are not just low, they are effectively zero, roughly 1 in 400 trillion. At that point, probability stops being useful and intent becomes the only remaining explanation. What makes this even more unsettling is what happened in the seconds immediately after the halt. The James Webb Space Telescope didn't simply observe a cold rock floating in space. Its instruments detected distortions in space-time itself around the object. The data resembles time dilation, the same phenomenon predicted near black holes and at relativistic speeds. But there is no black hole here. There is no massive star. There is only 3I, Atlas, sitting quietly, as if gravity itself had been asked to step aside. This forces a difficult conclusion. What we are seeing is not an astronomical curiosity, it is a demonstration. The physics involved exist only in theoretical papers, equations written on chalkboards, ideas that were never meant to be observed directly. Yet here they are, unfolding less than 1 billion kilometers from Earth. And based on telemetry collected over the last 6 hours, this object is not inactive. It is not drifting. It appears to be waiting. To understand how serious this is, we need to rewind to what 3I, Atlas, was doing before it reached Jupiter. Just 3 months ago, it was cataloged by the Atlas Survey in Hawaii as a standard interstellar visitor. Its trajectory was clear, its path predictable. It was expected to swing past Jupiter, gain speed, and leave the solar system forever. That is how gravity assists work. That is how they have always worked. But 12 hours before its closest approach, the numbers began to diverge from every model we trust. And that divergence is where this story truly begins. That divergence started quietly, almost invisibly, hidden inside streams of routine telemetry that scientists process every day. 12 hours before its closest approach to Jupiter, 3I, Atlas should have begun accelerating. Gravity is not optional. As an object falls into a massive well, like Jupiter's, its speed must increase. Yet the numbers showed something profoundly wrong. The velocity of 3I, Atlas, flattened. It held steady at roughly 180,000 kilometers per hour, as if Jupiter's pull simply stopped applying. That alone was enough to raise alarms, because resisting gravity requires energy. Passive objects cannot do that. But this was only the prelude. As the clock reached 4:15 UTC, the data crossed from alarming into impossible. According to live tracking from NASA's Deep Space Network, the object's velocity dropped to zero relative to Jupiter's reference frame. There was no deceleration curve. There was no thermal spike. There was no sign of propulsion. In classical physics, an instant stop like that would generate catastrophic forces, millions of Gs. Any known material would be crushed, shattered, or vaporized. But the object remained intact, perfectly stable, as if inertia itself had been switched off. The first assumption was still instrumentation failure. Extraordinary claims demand extraordinary verification. That verification arrived quickly. The coordinates were independently confirmed by European Space Agency's Gaia Observatory, which specializes in ultra-precise positional measurements. Gaia does not guess. It measures stellar motion down to micro-arcsecond accuracy. Its conclusion matched NASA's data exactly. Then came confirmation from ALMA in Chile, using millimeter wave spectroscopy to check momentum and emission signatures. ALMA detected no Doppler shift, no kinetic motion, no outgassing. 3 systems, 3 methods, 1 conclusion. 3I, Atlas was hovering. At that moment, the question stopped being whether the object had stopped and became how it survived doing so. Any natural body would be torn apart by inertial stress alone. Ice would fracture. Rock would pulverize. Even metallic asteroids would disintegrate. The structural integrity required to endure an instant halt at that speed does not exist in nature. It implies materials or mechanisms far beyond anything humans can manufacture today. The most disturbing confirmation came shortly after from Juno, which was close enough to directly measure Jupiter's magnetic environment. Juno detected a localized distortion surrounding the object, a magnetic cavity in which background radiation simply vanished, not deflected, not absorbed, gone. Inside this bubble, Jupiter's intense magnetic field appeared muted, as if the object had carved out a pocket of spacetime insulated from external forces. From a physics standpoint, this changes everything. To neutralize both gravitational and magnetic influence simultaneously, an object would need to manipulate spacetime itself. This aligns disturbingly well with theoretical concepts long considered unreachable, such as metric engineering, where space is bent around an object instead of the object pushing against space. In such a scenario, there are no felt g-forces, no inertia. The object is effectively stationary inside its own moving frame of reference. And then there is where it stopped. 3. Atlas, did not freeze at a random point near Jupiter. Trajectory analysis shows it parked precisely at the Lagrange point between Jupiter and its moon Ganymede. This is a gravitationally stable region, a natural parking orbit used in human space missions for long-term station keeping. Reaching that location intentionally requires detailed knowledge of the Jovian system and precise control over velocity and timing. This was not an accident. It was a calculated maneuver. At this stage, speculation becomes unavoidable. In theoretical astrophysics, there is a long-discussed concept, known as a self-replicating exploratory probe, often referred to as a von Neumann probe. Such machines would logically use gas giants as energy sources, drawing from their massive magnetic fields and radiation belts. Jupiter is not just a planet, it is a power station, and 3I, Atlas, is now parked beside it. 10 minutes after coming to a complete stop, the object did something else. It began to emit a signal, not noise, not random radiation, a structured sequence, mathematical, intentional. And what that sequence contains is the next piece of this unfolding puzzle, because it marks the moment when this stopped being an isolated anomaly and became a message. That signal was not something conventional instruments were designed to expect. It wasn't radio, it wasn't optical, and it wasn't a laser sweep. What arrived first was detected by instruments that usually listen to the universe at its most violent extremes. Gravitational wave observatories on Earth, including LIGO and Virgo, registered a faint but unmistakable ripple in spacetime coming from the direction of Jupiter. This alone was unprecedented. These detectors are built to observe black hole mergers billions of light years away, not localized disturbances inside our own solar system. Yet the signature was real, clean, and repeating. The interval between pulses was precise, 1.618 seconds. That number is instantly recognizable to anyone familiar with mathematics or physics. It is the golden ratio, a constant that appears throughout nature in spirals, growth patterns, and orbital resonances. But nature does not generate gravitational wave pulses on exact mathematical intervals with nanosecond accuracy. Even pulsars, the most stable natural clocks known, exhibit measurable drift over time. This signal did not drift. 6 hours of observation showed zero deviation. Precision like that is a hallmark of engineering, not geology or astrophysics. As scientists scrambled to analyze the waveform, optical instruments were turned toward the object. The James Webb Space Telescope focused its mid-infrared sensors on the region surrounding 3I, Atlas. What it saw raised even more questions. The object's thermal profile collapsed to near absolute zero within seconds of stopping. In thermodynamics, temperature is motion. To remove heat that quickly, an object must be isolated from the surrounding universe. There is no natural process that allows a comet-sized body to instantaneously shed thermal energy without radiating it away. The only viable explanation is the presence of a containment field, a boundary where external heat exchange is suppressed. Then came the visible light data. The Hubble Space Telescope attempted direct imaging. The resulting frames were not blurred or obscured. They were warped. Background stars appeared stretched and bent around the object, forming arcs consistent with gravitational lensing. This phenomenon normally requires enormous mass, the kind found in galaxy clusters or near black holes. Yet orbital tracking showed no measurable effect on Jupiter's moons. Ganymede, Europa, and Io continued along their paths undisturbed. This creates a paradox. Enough gravitational influence to bend light, but not enough to pull nearby bodies. The only solution allowed by general relativity is variable gravitational coupling. In simpler terms, the object is actively controlling how much gravity it exerts on its surroundings. At this point, the idea of a natural comet no longer fits any observed parameter. The data instead aligns with concepts discussed only in advanced theoretical physics. One such idea involves manipulation of the Higgs field, the fundamental field that gives particles mass. If an object could locally alter that field, it could effectively change its own mass, becoming heavy for lensing light while remaining dynamically light for orbital interactions. Under those conditions, stopping instantly is no longer destructive. It becomes trivial, and the signal itself did not remain constant. At 5 UTC, the pulse interval shifted. The 1.618 rhythm halved cleanly to 0.809 seconds, a perfect harmonic division. 30 minutes later, it halved again. This is not random modulation. This is a countdown. In engineered systems, countdowns precede transitions, activation, transmission, or synchronization. Meanwhile, magnetometer data from Jupiter showed a steady drain of energy from its magnetosphere. The object was drawing power directly from the planet's magnetic field at a rate that dwarfs human energy consumption. Gravitational waves do not attenuate like radio signals. They pass through stars, dust, and planets almost unaffected. A broadcast using this medium is not meant for a single receiver, it is meant for the entire galaxy. Which raises the most unsettling question so far. If this is a transmission, who is it for, and why begin sending it only after parking beside Jupiter? Because the next development makes it clear that this signal was never meant to stand alone. As the countdown continued, another instrument far from Jupiter detected something that changed the scope of the event entirely. The pulse from 3I, Atlas, did not just travel outward, it was answered. That answer did not come from Jupiter, and it did not come from deep space beyond our system. It came from the opposite direction, from within our own solar neighborhood. At exactly the moment the gravitational pulse from 3I, Atlas, reached the orbit of Saturn, instruments aboard the European Space Agency's JUICE probe registered a secondary disturbance. The timing was exact to within milliseconds. This was not an echo. It was a response. Saturn has always been a planet of interest to scientists, not just because of its rings, but because of the complex electromagnetic environment created by its moons. One of those moons, Enceladus, has long been suspected of harboring a subsurface ocean. What no one suspected was that something else had been parked nearby for years, silent and dormant. When the JUICE probe detected the anomaly, scientists immediately pulled archived data from older missions. Records from the Cassini spacecraft, which ended its mission in 2017, revealed a faint thermal signature near Saturn's E-ring that had been dismissed as background noise. At the time, it didn't stand out. Now, in light of the new signal, that dismissal looks like a mistake. The coordinates matched perfectly. The same region that once showed an unexplained heat trace was now emitting a gravitational pulse identical to the one coming from 3I, Atlas. Same frequency, same modulation. Same harmonic structure based on the golden ratio. Two separate objects, separated by more than 1 billion kilometers, broadcasting in perfect synchronization. The probability of this happening by chance is effectively zero. Natural phenomena do not coordinate across planetary distances with mathematical precision. Networks do. As analysts expanded the search, radio telescopes in New Mexico picked up a third faint but coherent signal near the orbit of Neptune. It was weaker, almost hidden in noise, but it followed the same timing pattern. 3 nodes. Jupiter, Saturn, Neptune. When researchers mapped the phase alignment of the pulses, the geometry formed a moving focal point. This was not a static triangulation, it was tracking something. That something was not a distant star, it was not the galactic center. The focal convergence was inside the inner solar system, moving along a familiar orbital path. It was tracking Earth. This was the moment the data was quietly classified. For 45 minutes, access was restricted while teams at NASA and ESA attempted to rule out error. But physics is unforgiving. Independent verification kept confirming the same result. The pulses were converging, and the convergence point followed Earth's position with unsettling accuracy. An astronomer at Caltech, recognizing the implications, leaked the findings. Not out of malice, but because withholding the information would not change the outcome. At this stage, The event could no longer be described as a single anomaly. It was a system coming online. A distributed system spanning the outer planets, each node positioned near a massive energy source. Gas giants are not just large, they are powerful generators of magnetic and gravitational energy. If you were designing a long-term autonomous network, these are exactly the locations you would choose. Meanwhile, the activity around Jupiter intensified. Thermal output from 3I, Atlas increased by over 400% in under an hour. The magnetic bubble surrounding the object expanded, pushing back charged particles from Jupiter's magnetosphere. Instruments estimated that the energy being absorbed could power human civilization for thousands of years. Whatever this object was preparing to do, it was nearly fully charged. The countdown accelerated again. Pulse intervals shortened. Synchronization between the Jupiter and Saturn nodes tightened, their signals overlapping in phase more frequently. This is what engineers call phase locking, a process used to align oscillators so they act as a single coherent system. In physics, phase locking is how you focus energy. Scatter becomes direction. At this point, there are only three plausible interpretations. The first is that this is an unknown natural process, some exotic interaction involving dark matter or vacuum energy that we have never observed before. If that is true, then our understanding of physics is incomplete at a fundamental level. Entire frameworks would need revision. The second possibility is that this is a probe, or rather a network of probes, created by a civilization capable of manipulating gravity, mass, and space-time itself. On the Kardashev scale, that places them far beyond us, capable of harnessing stellar or even galactic energy. The third possibility is the most unsettling, that this system is not merely observing, but preparing to act, because triangulation is not used for curiosity. It is used for targeting, synchronization, or construction. And as the energy output from the Jupiter node continued to rise, one fact became impossible to ignore. Whatever happens when the countdown reaches zero will not stay confined to the outer planets. The bridge being formed is directional, and all indicators show that its destination is already locked in. The question is no longer whether something extraordinary is happening. The question is whether we are about to witness first contact, first observation, or the first step of something far more consequential. With the triangulation locked and the energy draw accelerating, the scientific focus shifted from observation to prediction. Researchers began asking not what this system was, but what it was capable of doing next. Every model run from planetary science labs around the world produced the same conclusion. The amount of energy being accumulated near Jupiter was far beyond what would be required for sensing or passive communication. This was not a listening post. This was an active mechanism. The key clue lay in the way the gravitational pulses were interacting. When three synchronized sources emit coherent waves, they can create constructive interference. Instead of spreading energy outward in all directions, the waves overlap, reinforcing each other along a narrow corridor. In physics, this is how lasers work with light. Here, the medium was space-time itself. The pulses from Jupiter, Saturn, and Neptune were not random broadcasts. They were phase-aligned, shaping a directed structure through the solar system. As simulations refined, a disturbing pattern emerged. The corridor being formed was not static. It adjusted continuously, compensating for planetary motion, orbital drift, and relativistic effects. That level of correction requires constant computation and real-time feedback. In other words, this system was actively steering something or preparing a pathway for something to move through. Meanwhile, data from Earth-based observatories showed subtle but measurable effects closer to home. Sensitive instruments detected minute fluctuations in Earth's magnetosphere, far too weak to be dangerous, but far too structured to be dismissed. The timing of these fluctuations matched the harmonics of the outer planet pulses with near-perfect correlation. Earth was already interacting with the system, even though nothing had physically arrived. At the same time, infrared telescopes noticed a gradual increase in background noise across specific wavelengths. This wasn't heat in the conventional sense. It was vacuum excitation, a phenomenon predicted by quantum field theory when spacetime itself is stressed. Under normal conditions, these effects are only measurable near black holes or during the earliest moments after the Big Bang. Seeing them appear inside our solar system was unprecedented. The countdown continued. Pulse intervals dropped below half a second. The system was approaching a threshold state, one where a small additional input could trigger a large-scale transition. Engineers would call this a critical point. Physicists call it instability. Nature avoids such precision, machines seek it. The debate inside scientific circles became increasingly divided. One camp argued that this could be a form of cosmic infrastructure, a transit network built by an advanced civilization to move efficiently between star systems. If so, Jupiter was not a destination, it was a junction. Earth's alignment with the corridor could be incidental, a temporary overlap as the system powered up. The opposing camp was less optimistic. They pointed out that every parameter being adjusted favored alignment with Earth's orbit. The focal convergence tracked our planet not approximately, but exactly, accounting for orbital eccentricity and axial tilt. That level of targeting is not accidental. If this were a transit corridor, Earth was either in the way or deliberately included. Another troubling detail emerged from analysis of the original golden ratio signal. When researchers decomposed the waveform further, they found layered modulation beneath the primary frequency. These subpatterns were not random. They followed binary logic. On and off states, pulses and pauses, information encoded directly into the structure of spacetime. This was not just power transfer, it was communication embedded in physics itself. And yet, no message was addressed to us directly. There was no attempt to modulate radio frequencies, no optical signaling, no language-based encoding. That omission may be the most telling detail of all. Whatever this system was designed to do, human interpretation was not a requirement. The message, if it could be called that, was meant for the machinery itself. As the final minutes of the countdown approached, global space agencies shifted to continuous live monitoring. Every sensor capable of measuring gravity, magnetism, radiation, or time itself was focused on the outer solar system. There was nothing more to calibrate, no more data to verify. The equations had converged. The energy levels at the Jupiter node crossed another threshold. The magnetic bubble expanded again, and the gravitational lensing effect intensified. Space around the object visibly distorted, stretching background starlight into thin arcs. The corridor structure sharpened, its direction unmistakable. At this stage, there were only two remaining possibilities. Either the system would complete its cycle and stabilize, revealing itself as a benign construct operating on scales we are only beginning to comprehend, or it would initiate a transfer event, sending energy, matter, or information through the corridor toward its target. And as the final seconds ticked down, one fact stood above all others. For the first time in human history, we were not simply observing the universe. We were positioned directly in the path of something built to reshape it. As the countdown reached its final phase, the room for speculation disappeared. This was no longer a theoretical exercise or an abstract debate about advanced civilizations. The system had entered execution mode. The pulses from Jupiter, Saturn, and Neptune were now so tightly synchronized that the corridor they formed became mathematically rigid, like a locked beam etched into the structure of spacetime. Every model showed the same result. Once this configuration stabilized, it could not be easily undone. Earth's instruments began reporting effects that could not be filtered out as noise. Atomic clocks across multiple continents drifted out of sync by nanoseconds, then snapped back into alignment. Laser interferometers detected space-time strain far below destructive levels, but clearly artificial in pattern. These were not side effects, they were confirmations. The system was checking coherence along the corridor, verifying that the pathway was stable all the way inward. The most unsettling realization came from orbital dynamics teams monitoring Earth itself. Our planet was not being pulled, pushed, or accelerated. Instead, it was being referenced. The corridor adjusted around Earth's position, not the other way around. In navigation terms, Earth had become a coordinate anchor. That distinction matters. Anchors are not destinations. They are points of alignment used to ensure precision,